Thank you for giving me this opportunity to do a retrospective. I hope that's not to do with my age, but for the length of this program. And I want to apologize. I didn't realize, Gaiman, I should have honored UC San Diego, UC Los Angeles, San Diego State, UC Davis, Cal Poly, and put some slides in from them. So that's a bit of an error on my part. I do apologize. Some time ago, when this project started, this was the graph that we used a lot. And I have to say it was Ron Hoffman and Gaiman and Carl that taught me this graph. And since honesty is the best policy, when I came into this project, 2000, 2001, I didn't quite appreciate the type of challenge we faced in California. This is 2000 data, January 1st, 2000 to December 31st. And it was Ron and Gaiman and others that taught me that the special challenge we had in California was this big peak that we get in August and September. Even yesterday would have been a day like that. And that we had to address both commercial air conditioning and residential air conditioning. And today you heard many terrific talks that have done that. My colleague David Koller, who I respect enormously, created this almost unreadable eye chart, but he began to stress the point that Rajit Garg was talking about this morning. We need to move from demand response at certain times of peaks during the day to a collaborative grid where especially the intermittents that are coming in from the left through the transmission and distribution need to collaborate with our houses, with our big buildings, and send information back the other direction. And so, of course, 10 years later, everybody in this room, myself especially, and many of you already, knows that this is the next challenge that we're trying to face with the kind of sensors and information technology that we've seen today. I don't know whether I should show this. You could go back home and look at this, because one of them will take too long. But I can highly recommend that you go to Hulu or YouTube, look up those John Oliver links, and look up the Jon Stewart link. Have fun with your spouse or your family tonight and do that. Because if anybody thinks that there's still a debate going on about global warming, those are the funniest and most compelling YouTube links I can recommend. And I'll make sure I print this out so that you can get it later on without me showing the YouTube links. If I'd have had more time, I would have done it, but I don't think I should do that now, given the time. The reason I put impolite version, his impolite version is bad enough, and Rich Winslow, if he's still here, oh yeah, was kind enough to find me the edited version, and then the one that actually he showed has some blue language in it, so it's up to you about whether you want to watch it or not. This was a cartoon that Dan Chapman drew at my instigation. Actually, Dan Chapman is a fantastic graphics artist, and I don't think he's here right now, but I'd like to honor him. I give him these crazy ideas on the back of an envelope, and then he creates these great cartoons, and they last for many years. I see them pop up all over the place. And back then, 10 years ago, you can see from the hairstyle that that's me on the left and my wife on the right, sitting in a pretty good rendition of our kitchen. And the vision we had, I think, hasn't really changed that much, except that many of the lovely talks I saw today have put flesh on the bones of that cartoon with a new thermostat. And we, later on, will hear from Nate Ota, for example, and a new meter conveying the real-time usage back to the service provider, and the wireless beacons. And we've seen examples of that all morning. It's just rather lovely to see the flesh put on the bones of this early cartoon from probably 2002 or 3. These are some of the things that we built at Berkeley going from 2003. We had a little plastic house. Therese, you had one of those. I had one of those. We started putting sensors in the ceiling of Echeverry Hall. The hardware back then was rather large, but it still works and does well. And then we started putting them in houses out in the hotter part of the state on the other side of the Caldecott tunnels. We had another cute experiment where, with our energy scavenging device on the right at the bottom, we were able to power those smart moats. And for fun, we put them on the lower surfaces of this wooden staircase in a building across the road, and indeed found as early as 2006 that when people went running up and down the stairs between lectures, we could harness enough electricity, microelectricity, don't get carried away, microelectricity to power the device, going into that gigantic pack of supercapacitors there. Okay, the next thing is during another one of our power crises, we were lucky enough to be featured on AB7 News, or I should say Nate was, and I think Nate just came into the building. Where is he? There he is over there. He's more handsome now than he was back then. I don't know how you managed to do that. I feel like I'm going in the opposite direction. But this is fun to watch.
It's electricity on demand, kind of like video on demand, Howard?
Kind of like, and it is called a demand response meter. It's a wireless device that interacts with the power company so you can maximize your savings and minimize your consumption. This prototype residential energy management system isn't exactly designed for marketability, but it is designed to prevent California from sucking its energy grids dry. Engineering PhD candidate Nathan Otis says you decide how much you want to pay a month for electricity. The wireless system responds to the rising usage and decreases consumption during peak hours.
So this is a wireless sensor node.
The sensors gather the temperature in each room and send it to a home-based computer that creates a plan.
So averaging all the temperatures in your house for each room, playing optimization games to get the most for your money, the most BTUs for your buck, I call it.
The system interacts with wireless meters that PG&E is already installing in some homes.
So when that signal comes in from the utility company, my system will automatically adjust set points and adjust actuation to save energy for my preferences.
The energy management system also downloads all of its data on a remote database. Current systems cost several $1,000s, but the goal of the UC Berkeley research team is to drive the cost down to about $20 a unit and have it on the market by 2009.
So at a large scale, if everyone had systems like this, each person saving just a little bit would add up to a lot of energy, a lot of kilowatts being shed.
Eventually, the system can regulate every appliance in the house, like turning refrigerator compressors down at peak hours. Now, the research is being funded by the California Energy Commission and the Public Interest Energy Research Program, so it does have the momentum to end up in a lot of homes here in California. Reporting live in Berkeley, I'm Alan Wong, ABC7 News.
So Nate is going to give a talk on that in the afternoon session. And as you can see from earlier talks, those systems really are now being applied. On the other side of that, it was Richard Hsu over here that gave the introductory talk and showed how that kind of technology is being used in that Chicago building. My colleague David Culler always felt that this building that we turned into a test bed was impenetrable from the point of view of the software, and he's right. He designed this system, a software system that would enable us to talk to the various devices in the building and therefore able to get the real data that we wanted from the system. We started out with Corey Hall on a web-based environment, and then we got into a gateway system with Professor Culler and Professor Auslander. And then, even though this is a very pro-Siemens slide, we started applying that to this building about 3 or 4 years ago.
The University of California, Berkeley is home to the Center for Information Technology Research in the Interest of Society, or CITRIS, a unique four-campus collaboration to turn technology into solutions. Not only is Sutardja Hall CITRIS headquarters, it's also an essential part of cutting-edge research that uses the building's automation system as a test bed.
This building's special because it's a living laboratory, and that was the intent of the building when it was first being designed, that students would be able to use the automation system and the HVAC system as part of their research. Being able to accommodate the research needs, that's what we're here for. We have to make sure that's our #1 priority, but also do it in the most efficient way possible.
In 2009, a campus-wide effort to lower overall energy consumption was initiated. A new department called the Energy Office began shifting responsibility for energy usage to each building's facilities manager.
CITRIS is one of the more energy-intensive buildings on campus because of the research labs and between foresight and operations. So our goal for Citrus, working with Domenico, is to drive down electricity use. We want to explore different strategies, different mechanisms to drive down electricity and steam usage.
My role has been to support Domenico in meeting his energy goals and meeting his challenges. So basically being a partner for Domenico.
The Apogee building automation system with BACnet Open Protocol was the obvious solution for achieving tight, efficient systems control while allowing for the customized programmability needed for ongoing research.
We have a number of different CMIS panels throughout the building, roughly 15 main panels that are controlling everything from the exhaust fans inside the Marvel Nano Lab to the 140 different VAV boxes that are supplying heating and cooling to the different zones throughout the office portion of the building. We have over 40 different sub-meters in the building right now that are looking at loads on different portions of the building. And we also have a number of different sense points.
The flexibility of Apogee is that it acts as a data management platform as well as a building automation platform. It's a backbone that allows data to be shared with others so that they can build on top of it and build new technologies and actually do research.
Data collection is key to achieving the goals of Citrus and its researchers. Access to that data is a critical part of those goals.
What do you do with all this data and how do you archive the data? I think just having access to the data and having access to the real-time data is the first step.
The Green Touchscreen provides real-time data of energy, water, and steam usage, as well as providing a lot of green tips. And by providing data like this, you're allowing a person to engage with the data, and you allow a person to really educate themselves to make more conscious decisions about their behaviors and really empower themselves to reduce energy themselves.
One specific innovative research project using Sutardja Hall and its substantial amounts of data is demand response.
Demand response is essentially the methodology of shifting loads so that they are off-peak. And we've gone through the process of figuring out what is the data, what data do we need, how do we get data, shifting load by shutting things down, moving them, and utilizing the capacity that we have for thermal storage, getting people to move and reorient their behaviors as they relate to electricity consumption.
There's no other facility like this, at least on the campus, where students are able to not only collect and monitor the data, but also use the building and the controls to run some experiment and look at the savings.
I see the future of energy efficiency on campus following the industry trends. More buildings get more automated, become more efficient generally with more controls.
I don't think we'll ever be at the point where we said everything's done in the building. It's always a moving target, and trying to trim down our consumption and look at ways to save energy, I think will continue for probably forever.
We have responsibility. You know, with great power comes great responsibility. Literally, there's a great amount of power here. So we have a responsibility to cut that down.
So that's it. I thought that would be a nice place to end the morning with letting you go to lunch. Thank you very much for a wonderful morning. I want to thank Therese and Gaymond and Carl for being the organizers of the meeting. Thank you for all the great discussions. And at 2 o'clock, please come back for Nate Otter, who now works for the radio company. No, what is it, Nate? Radio Thermostat Company of America. And I know his talk at 2 o'clock will be absolutely spectacular. He is one of our poster child students become commercial organizer. And once again, thank you very much for today, and have a great lunch, and I'll see you at 2 o'clock. Thank you.